We're studying IGCSE physics and we're starting space physics too. To recap, Amina, what did we do in the last class? Quick recap. Amina,
Yeah,
recap.
I
What did
don't
we do
think
in
I
the
was
last
there
class?
in the class.
You were there. Manvi, were you there? Or Ayan, tell me,
No.
recap.
Sir, we discussed rotation, revolution, phases of the moon, and some facts about the moon and the sun.
All right, so we looked at Earth, we looked at Moon, and we looked at rotation, revolution. We looked at seasons and day cycle. That's what we did. I mean, I remember.
Yeah.
Could
Okay,
you do
good.
seasons and day cycle again? Because I wasn't present last class.
We'll do it one more time, all right? But we'll do that as soon as we finish this part of the chapter. Then we'll start doing questions, and then we'll revise the whole chapter one more time, all right? I'll send you the recording of the last class. Watch it. Watch the recording, and then we'll do questions on it. That would save our time as well, and it would be better that way, right?
Yeah.
Just a second. So, Ritika, we're studying space physics today. Now, since this is not the first class on this, if anything is, let's say, confusing, or if you don't understand something, then please feel free to ask me. All right, Ritika?
Sure.
Now, in physics, it's not biology, it's not chemistry. So in physics, we can study any chapter we want, and it's not going to be, let's say, that much confusing compared to chemistry. Now, there's no way you can do chemistry chapter number 11 without doing other chapters before it. Similarly, in biology, that's also the case when physics, we can do any chapter we like. So we're starting this, solar system 2. Man, we start reading.
Mercury is the closest planet to the sun. In many ways, it's a larger version of our own moon. It has a cratered surface and no atmosphere.
All right. So now we're looking at a few inner planets, right? Our solar system has 8 planets, and our job is to look at these planets and see how they work. Now, before we look at all of these, just a second, I would like to revise one thing from the last class, especially, which is called the orbital velocity. Now, everyone write this in your notebook, because this is much more important. What is orbital velocity? Well, orbital velocity is if you have any object orbiting. Let's first look at what this word means. Orbital. What does that mean? Well, that basically means anything that orbits, right? Anything that is orbiting. If that is what it means, what does it have to do with velocity? What is velocity? Velocity is the rate of change of distance. Rate of change of
Speed in a
distance
given direction.
over time. Right? Distance or speed, basically, in the direction. Velocity is a vector, so it has a direction as well. But okay, that's great. Now, if I move on, if I show you the sun, our sun. Now, not the best graphical image right now, but this will do the job. All right. Now imagine that is the sun, and we have an orbit right here. Let's imagine the orbit to be circular, even though the orbit is not circular for the Earth. It's
elliptical.
Elliptical. Yeah, it's a bit elliptical. Fine. But we don't care about that. We're going to assume it's circular because it is almost circular. Now, if I imagine the Earth is right, let's say this is the Earth, and we'll make another sun right here. That's the sun, and that's your Earth in this orbit. And my Earth is moving like this around the sun. This is called, what is this called? Is it rotation or revolution, Ayan?
Sure, that's revolution.
Revolution, exactly. Now, one revolution takes 365 days. So to go from here to here, we know that it takes how much? 365 days. That's fine. That's okay. Another thing is, if you have a circle, let's make another circle right here. This is a circle. Perfect. If I have a center right here, that's the center. Now, can someone tell me how do I find the length of the circle? How do I measure the length
2
around the
pi
circle?
r.
2 pi r. Now, this length around the circle is called the circumference. Ritika, what is it called? Circumference, which is 2 pi r. That's perfect. Now we know that. So I can say that this whole distance around the sun is going to be 2 pi r because it's a circle. It's going to be 2 pi r. From here all the way to here. That is going to be 2 pi r. And I also know that one revolution takes 365 days. That's the time. So we've gotten the time for it. And we have one more thing now. We have the distance. And the distance is 2 pi r. Now that r is actually going to be just the radius from the center of the sun. That's your radius. Fine. Now our job is to find out, let's say, what is the speed of the earth? How fast is the earth moving? How can we do that? Now to do that, we'll have to use the formula. We'll just use the velocity formula, right? Or let's say the velocity. If I say velocity is distance, it's actually displacement over time. Displacement is the same as distance. The only difference is that it has a direction. So displacement over time. Amina, what is displacement?
The same as distance.
Distance, right? But it has direction. Now, okay. But I realize that the displacement is going to be, or the distance right here. Let's remove the word and just keep it as distance for now. And since I know the distance is 2 pi r, we know that already. And I know the time taken is 365 days. That is now going to be my, or instead of saying 365 days, let's just write time t. Now t could be anything, right? T could be anything. For different planets is different. So this right here is my orbital velocity. Any questions?
No, sir.
2 pi r over t. Now fine.
So we do not consider the elliptical orbit. We do not consider the ellipse as the shape. We take it
No.
as a circle.
Yes. Even in class 11, even in for class 11, 12, we'll also be doing the same thing. So we
Oh.
don't take it as an elliptical.
And how do we
that-
find out the distance?
How do we find the distance, right? Well, you know 2 pi r, we know that already. But there's something we don't know, which is
What's r?
what's r exactly. To find the r, let's write the definition here. What is the radius? What is r? This r is basically the radius, which is equals to, okay, write all of this in your notebook, by the way, the whole thing from here. The radius is distance from center of object, let's say center of sun, could be any object, to earth.
Oh, so is this only specific for Earth or for every planet?
No, let's just say distance from center of one object to another. Examples could be sun to earth. So you have to take it from the center. The key word over here is center. Manvi, do you read that? What is it?
Yeah, center.
Center. Now this is not the radius, by the way. One big problem people do is they take this as the radius. which is clearly not the radius. If this was the radius, your circle would not rotate, it would rotate around this point. Your circle would look something like this. Right? We don't want that. We want the radius from the center, which is going to be there. Now we look at a few questions in a second. But I think that's it. So write the radius definition. R is the radius. 2 pi r and time, what is time? T. That is also important. T is, let's say, it's called time period, which is time taken for one oscillation. Or not oscillation, let's just say revolution. Now these will be asked in the exam. And since this is a new chapter, it is guaranteed to be there in the exam. Right? It's a guarantee. Now, Ritika, are you writing?
Yes, sir.
Good. Anas?
Yeah.
All right. Amina, any questions? Ayan, any questions?
Nope.
No, sir.
Nope. All right.
Wait, 1 second.
All right. Anas, ask.
No, I don't have a question. I'm just writing right now.
Right. Yeah, take your time. Honestly, take your time. Tell me when you're done.
Okay, done.
Done, sir.
Okay, we'll do one question on this. I really want to do a question on this, right? Let's look at this. You have your Earth right here. Let's call this as the orbit. Then I'll make the sun right here as well.
Can you go back to the notes for a second?
Yep, sure. Take your time. Everyone finish writing? We'll only move on when you're done. The rest of you look at the right side of the whiteboard. So this is the orbit we have. Now inside the orbit we have sun, and we also have the Earth right here. Let's make Earth with a with blue color, because Earth actually looks blue in space. Quite blue. It's also the Earth is also called the pale blue dot. Another name for Earth is the pale blue dot or the blue marble. Now they won't ask you this in exam, but that's just something you should know because we're doing space physics, right? A better word would be for it would be astrophysics. Now the sun is right here. We have the Earth. Let's find the orbital velocity. You have a few things given to you. What is given to you is distance between Earth and sun, and we say radius of sun. Or let's try for the moon. We have done sun already. Let's try moon. Now time period is also given to you. We did in the last class that time period is 27.3 days. And what else do we need to know? We know that, yep, everything is given. Now start solving the question. I'll tell you the distance, just a second. The distance is 6400 km.
Did you also do the stars and the supergiant and the red nova and all that?
Not yet.
Oh,
Just a second. I'll give you the distance between the Earth and the moon. Ayan, please check your notebook. I think we did this in the last class. Can you tell me the value of the distance between Earth and the moon?
Do we write that? The distance between Earth and
Sir, I don't have it noted down.
All right. This
I don't
one.
think we did it. It was in the textbook.
Where's in the textbook? So let's take this another example then. Let's say
Are we required to know the distance between Earth and Moon though?
no, it will be in the question, right? It will be in the question.
Yeah.
Let's try this one. Let's try any other object, or let's say a satellite, right? Now start the question. The radius of Earth is this much. The distance between the Earth and the satellite is this much. Your job is find the orbital velocity.
Is that the accurate radius or is it a made up value?
It's the accurate radius, approximate.
Okay. Okay.
Now, Ritika, I want you to work with me. So start reading from here. Read the formula for orbital velocity. Ritika,
Yes, sir. Okay.
can you hear me?
Yes, sir. Yes.
All right. So read the formula for orbital velocity out loud. Over here. This,
2 pi r by time.
so time, or 2 pi r by t, which is the time period. So now in this question, yes, Ritika, the time period is
27.3 days.
okay, and so we have E is equals to 2 pi r by t. Okay. Now we know that the time period is 27.3 days.
So do you want it in kilometers per day or kilometers per hour?
Kilometers per second.
Okay.
So do we take r to the other side?
Now, firstly, you're trying to find the velocity v. Now, let's see what is given in the question. They're giving us the radius of Earth. Let's say the radius of Earth is from here, from the center till over here. This much is the radius, right? Of Earth. Let's say that's R E. Now they've given us one more thing. The distance between Earth and the satellite. That's the distance between the Earth and the satellite from here. And how much is that? That's 560. And this one was 6400 km. Now our satellite is right here. Our job is to find R. Now, Ritika, what do you think R is in this case? Or how do we find R for our orbit? Amina, can you hear me?
Yeah, I can.
All right. Now, what is the radius of an orbit? Read the definition.
Radius of orbit is distance from center of one object to another object.
Right. So basically, it's the distance from the center. So now they've given us the radius of the Earth, and they've given us the distance between Earth and the satellite here. Now, what do you think is the value of R in this case? This R.
560 plus 6,400.
560 plus 6,400. Because look, my job is to find the total thing. Ritika, our job is to find the total thing from here.
Yes.
From here to here. From the center till the orbit. Therefore, they haven't given us the whole thing. They've given it in parts, and our job is to add the part together, the radius and the distance, to get the radius of the orbit.
I have the answer.
You have the answer in the chat. Whoever has the answer, whoever gives it first gets 2 points. Ayan, Manvi, Anas, let's see who gives it first. So 2 pi r. R is going to be 6400 km plus how much?
Uh,
560.
the answer is 229. Oh, chat.
Don't say it. Chat. Now, how do I convert days into seconds, Amina?
Multiplied by 24 and 60 and 60.
60 and 60. So each day is 24 hours. Each hour is 60 minutes. 60 minutes. Each minute is 60 seconds. If I solve this, I will get the answer. Ritika, tell me the answer. Amina, write the answer in the chat.
Sir, so 2 pi plus 2 pi into it's 6960
All right, just a second.
by so I'm just calculating the
Can you see the calculator on the screen?
yeah.
Now let's use it. 2 pi.
Can you check my answer?
I'll check your answer just a second. 560 divided by 27.3 into 24 into 60. 60. The answer is this much. So 0.0185 km per second.
I got a different answer.
Got a different answer. Anas, your answer is correct. Who's this one? That's Anas. Amina, your answer is correct. Ayan, where is your answer?
So I don't really have my calculator at the moment, so I was just watching you do it.
Not acceptable. All right, get your calculator.
So I left it at school.
Now that's also not acceptable. Fine, let's continue then. So pay attention, all right? And you have to give the answer if I ask you whenever, right? In terms of, so I'll do the calculation. No worries. Now the answer for Manvi, why is it incorrect? So Manvi, what did you take as the radius? Tell me.
Oh, I took the radius right. I didn't multiply 24. I just did 3600.
Right. So 24 is also important. 3600 is for hours to seconds, right?
Yeah.
And I would prefer if all of you do it step at a time. So now, what if you have to convert EA to EAs into days? Well, we know that each year is 1 year is 365 days. And in the same way, we'll multiply all of this into hours, which will give me 24, then 60, and then 60 for seconds. So multiply all of these. If they give you years. Now, I think that's clear for everyone. The only problem I want you to highlight was that you must add the radius and the distance together to get the actual radius of the orbit. All right. Now let's continue with this. The inner planets. All right. Now the inner planets, you have a few of them. You have Mercury, Venus, Earth, and Mars. And the other four are called outer planets, Saturn, Uranus, and Neptune. Now, Pluto is actually a dwarf planet. Okay, it's not one of the main planets. It's called a dwarf planet. We'll look at it. We'll look at why later. Now, firstly, I'm gonna read from here. Venus.
Yeah. Venus is the brightest object in the night sky, apart from the moon. It is almost the same size as the Earth, but conditions there are very different. The planet is covered by thick clouds of sulfuric acid, and its atmosphere causes a severe greenhouse effect. Down on the surface, the temperature can reach nearly 500 degrees Celsius.
Ayan, read.
Earth is the only planet in the solar system known to support life.
All right. The only planet in the solar system, well, in the galaxy as well. As far as we can see, we have not really found life anywhere. But we have seen planets which can support life, but we don't really know if life is there or not, because well, we can't go there. The planets are very far away. We found planets called uh, habitable planets, which have the perfect conditions for life, but there is no way to actually go there and check. Now Mars. Anas, read.
Okay. Mars is sometimes called the red planet because of its surface color. It has a thin atmosphere, mainly carbon dioxide, a dusty surface, and polar caps. From the shapes of some of its valleys, scientists think that the water may once have flowed there. It also has volcanoes, although none are active.
All right. Now I'll tell you what we need to study in this. Uh, Actually, read from here. Start from here. Ritika, read this part. Hurry up.
Asteroids have dimensions ranging from a few kilometers up to 1,000 kilometers. Most have orbits between those of Mars and Jupiter, but some have much more elliptical elliptical orbits that cross the paths of the other planets. There are some evidence that around 65 million years ago, an asteroid about 10 kilometers across struck the Earth. The effects of this may have caused the extinction of the dinosaurs.
All right, just a second. Now, what are we studying in this part of the chapter? Right? What is the goal? Well, the goal is to look at a few things, such as in the solar system, we have to look at one, the planets. Second, we'll have to look at asteroids. We'll have to look at moons. We'll have to look at comets.
So does every planet have a moon? I know about Earth and Jupiter.
Yes, other planets also have moons, not just satellites. They do. So we look at all of that in a second. Another thing is, which is more important, that is elliptical orbit. All right.
Sun isn't at the center of the orbit, right? It's one of the foci.
Yes, it's not at the center. Exactly. So let's start with the solar system. So we'll start with the solar system. What does it have? We'll also look at something called the star. The star is sun. Start writing now. Star is sun. The planets, I'll give it to you in the order, right? I need to memorize all the names of all the planets in order. So the first one is Mercury. Second one is Venus. Third one is Earth. Tell me if there's anything wrong. I'll correct it. Now these are the planets. There's one more actually. No, that's it.
What's the difference between comets and asteroids?
Comets are smaller.
Okay.
Comets are very fast. Another thing is comet orbits the sun, but the asteroid does not orbit the sun. We'll look at that in a second. Now, firstly, I'll give you Finish writing quickly. Um, okay, this is what you have. Let's check. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Right after this, we also have a much smaller planet like this, which is Pluto. Pluto is very small. Now, dwarf planets. Finish writing only till here.
What do you mean by like dwarf planets?
Yeah, that's what we're going to do now. So let's go here. अरे read the highlighted part है यार. Ayan, read.
Jupiter is more massive than all the other planets. It is mainly gas. The Great Red, no solid surface. Great Red Spot is a huge storm that has raged for centuries. One of Red's moon's Io.
Io is the moon of Jupiter. There's other moons as well. We'll look at that in a second. Now Saturn is also a gas giant. We call these guys gas giant. Now it has thin rings. Again, not a solid mass. And it has, let's say, these pieces of ice floating together which make up this ring. Now, Man, we read from Uranus.
Okay. Uranus is another gas giant. It's unusual that its axis of rotation is tilted at more than 90 degrees. It too has rings, but much fainter ones than Saturn.
All right. Let's see how we do this. Let's go back to the whiteboard. I'm going to give you a few important things about all of these planets, which you must remember. Mercury, closest to Sun. No atmosphere. Venus, brightest in the sky. High temperature. Earth is basically only habitable planet.
What do you
Are
mean
you writing? Yes.
atmosphere?
Ask me. Say it one more time.
What do you mean by thin atmosphere?
Thin atmosphere. Well, Earth has an atmosphere, right? where all the gases are there. You have nitrogen gas, you have hydrogen, you have oxygen, which we breathe, carbon dioxide. But on Mars, there's very little gas, which is let's say trapped in the atmosphere, right? Which can basically trap heat and do everything. Mercury has no atmosphere. What does that mean? Well, if you have Earth, you see that atmosphere, we have the ozone layer and everything, where the light comes in. Let's see, this is the Earth, or let's say this is the Earth. And around the Earth, we have this atmosphere, a blanket of gas. What is it? A blanket of gas. But if I don't have this atmosphere, what will happen? All the gases will rush away from Earth, and we'll have a vacuum. No gas is left. If I remove this, do you understand, Amina, everyone else? So this
Yeah.
atmosphere is basically what keeps all the gases to the planet, so you can breathe and do everything. But if there's no atmosphere, then you cannot breathe on that planet. There's no ozone layer. Gases are not trapped. So it's basically you over here, and then there's space, vacuum. If you were on, let's say, Mars or somewhere. But on the other hand, if you're on Earth, you don't have vacuum directly. You have the atmosphere, and then you have the space vacuum. Now, these are just some facts you need to remember for these. Planet Saturn is a gas giant and has thin rings of ice.
Sorry, I forgot Jupiter.
I did. Yes.
Sure, I have a question.
Ask me.
How big does an object have to be for it to be a planet?
It has to be bigger than the moon. That's one. Bigger than most moons. Now that's the thing. There's a problem. We'll talk about dwarf planets in a second. So it must be bigger than a moon. That's the big thing. And it must, let's say, orbit the sun. That's another thing. Those are one of the aspects. Now you need to realize that planets were being identified centuries ago or thousands of years ago. Now what that means is the definition has changed over the time. We look at that. Now Jupiter is most heavy, or let's just say heaviest gas giant.
Also,
No,
is it necessary that all planets be of one state? I mean, is there a liquid planet as well? Because there's gas and solid.
yes, there is. Liquid planet. We have a planet of water and ice. I think that's Neptune. And on that planet, it rains molten diamonds. Right? That's one thing. Now we have heaviest. The outer you go from, the more away you go from the sun, the more you become from solid to liquid, from gas to liquid to solid, something like that. Right?
But
Unless if you don't have an
technically,
atmosphere.
near the sun, the temperature is higher, so shouldn't the planets near the sun be liquid or gas?
It's not just about that. It's also about the contents of the planet. Now, if the planets are gas themselves, they're going to stick together. Gases like hydrogen, helium. But if you have iron is never going to be gas. The temperature is just too high for it to be a gas. Iron, or let's say aluminium. So planets like Mars and Earth have lots of metals in them, and these metals are what make them solid. Right? But Jupiter does not have all of these metals or these solid metals which have a very high temperature. It has gases. That's the difference. That's not just about the temperature. It's more about what is the planet made up of. If the planet is gas, there's no way it's going to become solid suddenly. If it has solid particles like metals and all of these heavy transition metals like iron, copper, gold, all of these things, they're going to be solid. I finished writing quickly. Ritika, are you writing?
Yes.
Good. Now to answer Anas's question, what is a dwarf planet, right? Anas, did you ask that? Anas? So what is a dwarf planet? Dwarf planet is basically a planet that is too small to be a planet, and it does not meet the criteria of let's say uh, have. So look, uh, you must be very large, massive one, and you must have small moons. Now the moon of Pluto is about the same size as Pluto. So we can't really. And another thing, the Pluto does not have a perfect orbit around the sun. So it has a very changing orbit. That's why it's a dwarf planet. Is that clear? The word dwarf means small. So it's very small and does not have a perfect orbit. So that's why it is not a planet anymore. Anas, can you hear me?
Do we also need to remember that it rains diamonds on Neptune?
No, not at all. Well, I love physics and I've been a great enthusiast of physics for a long time. So that is why uh, I'm telling you all of this, right? Because you should be interested about physics, especially astrophysics, right? But the only thing you need to memorize are the things on the board, and these are also a lot more detailed. Uh, these questions may come, all right? When they do come, you have to be ready to answer. That's our. So we are ready. We're ready for any question that may come. So nothing unnecessary and nothing left out. Now comets have a big deal, which is the orbit. Uh, Orbit around sun and highly elliptical orbit.
These are also called shooting stars, right?
Yes. Shooting stars, all right. Shooting stars are actually meteors, meteorites, not comets. Now, shooting star is not a scientific terminology. Anything that is moving very fast in space is basically a shooting star. When you see it in the space, in the sky, and it's moving very fast, you call it a shooting star. Comets look like shooting stars, yes, but those are meteors. Meteors are falling on Earth, so that's different.
What's a meteor then?
You look at
Difference
that, yeah.
between meteor and comet and
Look at that.
asteroid.
Yeah. And we look at first what a comet is. Several kilometers, or head of comet has several km of ice that melts to create visible effect of a tail by reflecting sunlight. Evaporate. Now, comet has a tail, okay, a head and a tail. So head is basically ice, and tail is basically the evaporation. That ice evaporating into dust and water. It's ice and dust. Okay. On the other hand, meteors are something else. These are tiny objects in space that right, tiny objects in space occasionally hits Earth, or let's say yep, hits Earth and or not, enters Earth and burns up in the atmosphere, creating a streak of light. Now, the streak of light is called the shooting star. Called meteor. To finish writing this quickly, the next thing we have is called satellite. The two types of satellites: natural and artificial.
So can you scroll a little bit down?
Amina, how much have you written?
I'm writing asteroids.
All right. Ritika,
So I'm in the middle.
Ritika, how much have you written? Ayan, how much have you written?
What's sir?
How much have you written so far?
Oh, I'm on satellites.
Satellites, all right. Natural satellite is basically something natural orbiting. Let's just say natural satellites and moons. That's all you need to know. They don't ask you the definition of natural satellite because it's basically a moon. Or let's just say Next thing we have is we look at asteroids and comets. We look at that again. Now please cut this part out. The last one. Asteroid don't orbit sun. Remove that line. Because they actually do orbit the sun. But their orbit is not elliptical. The comet is elliptical. These guys don't have an elliptical orbit. Instead of this, don't orbit the sun, right this part. Small rocky object which orbits sun. And in comets, add one line. Asteroids are small rocky objects that which orbit the sun, but comets are, let's just say, objects of made up of ice and dust, which orbit the sun. So comet is ice and dust. Asteroid is rocky.
So asteroids do orbit the sun.
Yes, they do. But what we need to realize is their orbits are not. They're not fast. They're not. Let's say they don't have an elliptical orbit. Now, one thing you need to write just below this is important, which is asteroid belt lies between Mars and Jupiter. Now, these asteroids are, let's say, they float around in space. But you need to realize that everything in the solar system is orbiting the sun, technically. All right? All of them are orbiting the sun. Because if the sun is here, all of these things around it are slowly moving with the sun as well, slowly. But not like a comet. Comets are like these. They have these tails, and they come here very fast, and they go around very fast. So they move like this. This is a comet, but this is basically an asteroid moving slowly. Comet is ice and dust, and asteroid is rock. I think we've written everything about comets and asteroids, nothing else remaining. We have done small planets and large planets, right? Now, who's still writing? Tell me. Ayan, have you finished?
Yes, sir.
Ritika, Amina.
Sir, I'm writing the artificial sun.
Amina, have you finished? Where are you writing?
Satellite types.
Satellite types. Take your time. Right? If there's anything else which we have to do here. Now, one main thing is about you have to look at the gravity. Before we look at that, I'll give you a few more examples of artificial satellites. So ISS is one of them. But instead of ISS, I would prefer if you write communication satellites, monitoring satellites, navigational satellites. We'll read about all of these afterwards. Communication, monitoring, navigation. There's one more, which is, yep, that's about it. Before we finish, and Manvi, have you finished writing?
Yeah.
All right. Anas,
Yep.
okay, then we're just going to read this for a second. This part, which is the main thing. Amina, start reading.
Okay. With no force acting on it, a planet, a moon, or any other object would travel through space in a straight line. To move in the curved path of an orbit, there must be an inward force acting on it. That force is provided by gravity.
All right. For things to move in space, uh, if there's no gravity, then everything will move in a straight line, like gas particles, Brownian motion. They move in straight lines. But gravity is what causes all of them to have an orbit. Now, this force of attraction because of gravity is what is causing the orbit. Fine. Now, gravitational attraction is between all masses. Between all masses. And okay. Gravitational force weakens with distance. So we'll read the rule in a second. It's no. Let's go over here.
Sir, time's up.
Time's up. Last thing, which is gravity. Write this and we're done. Basically, what we need to see is gravity is attractive force, keeping all things in space in orbit. Between all masses, directly proportional to product of masses and inversely proportional to square of radius. Let's say distance. Now this right here is called Newton's law. Finish writing this and we're done. Then in the next class, we'll look at accretion model, and gravity, and stars and the universe. Gravity is done. Accretion model and stars and the universe. Now, I'm gonna recap what did we study in this class.
Yeah. We did orbital velocity, and then the solar system, comets, asteroids, meteors, and gravity.
Gravity is just a thing. Right here, these in these, I want you to add one line right here. But have you written these? Have you written these
Can
names
you
of the
show us the
planets?
gravity definition once?
Right, just a second. I'll show you that. Have you written this, Manvi? The planet names.
Yeah. Yeah.
Now I want you to do this. Just use these four and make a line like this, the way I'm doing it, and call the last ones gas giants.
And the other ones are inner planets, right?
They're rocky. Well, inner and outer. So these are inner. Let's add one more line here. These are inner. and these are outer. Finished?
Can you show the gravity thing once again?
All right. So all of you write this: rocky gas giants, which are the last four. The top ones are inner, the last ones are outer. And in gravity, okay, look. We look at the specimen paper in the next class as well. We'll solve some questions on this. Like our job is to learn everything properly and once. So we don't have to get back to this again and again. We'll only get back to this to revise, not to learn new things, right? Not because we missed something. So I hope you've written everything down because everything is important. And in the next class, we'll apply all of this knowledge. First, we accumulate the knowledge, we gather all the knowledge together in our notebook, and then we use that knowledge to answer questions, especially partial questions. Now, my specialty lies in telling you how to solve papers and time management and everything, the formats and everything. So we'll do that when the chapter is done. Now, Manvi, have you finished writing? Everyone who has finished
Yeah.
writing, say yes, sir.
Yes, sir.
Others?
Yeah.
Sir, I'm almost done.
Okay, Anas, Ritika,
I'm done, sir.
I didn't hear you. Louder, speak louder.
Sir, I'm done.
Yeah.
All right, perfect. Now that's all for now. We'll see you in the next class.
Done, sir.